Huntsville, Alabama is home to the U.S. Space and Rocket Center. Every year, about 20,000 children from around the world visit here. They are participating in the immensely popular Space Camp program.
Let's see that bunny hop. Let's see you jump. There you go. Lots of hands. Make sure you're smiling. There you go.
This microgravity training chair simulates what 1/6 of the Earth's gravity feels like, making you feel like you're walking on the moon.
There we go. Wave to the people down on Earth.
The multi-axis training simulator creates the sensation of what it's like to lose control of a spacecraft. The camp's most popular attraction is one in which visitors perform work outside the spacecraft.
All right, now go to your right. All right, stop. Don't cross your leg.
Satellite repairs are made from the robotic arm. Almost everyone has seen this on television or in magazine articles. The shuttles have brought space exploration closer to us. A graduate of Space Camp has even gone on to become a real astronaut. Dorothy Metcalf Lindenberger attended the camp when she was in junior high school. 20 years later, in 2010, she was aboard the Space Shuttle for a mission to the International Space Station. The Space Shuttle is a spacecraft that can make multiple journeys to space and back, carrying passengers and cargo. It has a length of about 60 meters and a total weight of about 2,000 metric tons. It is one of the largest rockets in the world. The shuttle is propelled by 3 main engines and 2 solid rocket boosters on its sides.
4, 3.
The 5 engines produce more than 3,000 tons of thrust.
Booster mission liftoff from Space Shuttle Discovery.
After being launched, the shuttle makes a rapid ascent. It reduces its acceleration temporarily to counteract the stress imposed on its body, and then picks up speed again. Two minutes after takeoff, the rocket boosters are exhausted and ejected into the ocean. They are later retrieved for reuse. The external fuel tank is also jettisoned. It is the only component that is not reused. The backside of the shuttle houses a large payload bay, which has the capacity to carry a little more than 20 tons of cargo. When needed, laboratories that are used to perform various experiments are installed in the cargo area. Inside the shuttle's nose, under the cockpit, are the living quarters. Up to 7 crew members who work in shifts reside here. From the cockpit, the large robotic arm attached to the shuttle can be maneuvered. After completing its mission, the Space Shuttle reduces its speed to re-enter the Earth's atmosphere. Hurtling towards Earth, it faces temperatures hot enough to melt steel. Approximately 30,000 heat-resistant tiles protect the spacecraft and its crew. These tiles also help to ensure that the shuttle can be reused. After re-entering the Earth's atmosphere, the shuttle uses its wings to glide through the air and land. With reusable components enabling it to make multiple journeys into space, the shuttle was a groundbreaking spacecraft.
Journey. And to the ship that has led the way time and time again, we say farewell, Discovery.
In the 1960s, the American space program set its sights on the moon. The race between the United States and the Soviet Union to land a man on the moon was won by the Americans when Apollo 11 made its lunar landing in 1969. However, the Vietnam War was becoming increasingly contentious during the same time period. The increase in military spending led to budget cuts for the space program. In 1970, the end of the Apollo program was officially announced. But NASA had not abandoned its dreams of exploring space and was already taking steps towards an ambitious new plan. One that involved building a space station. In order to travel beyond the moon to other planets, a space station was required to gather knowledge about spending an extended period of time in outer space. Multiple trips to transport astronauts and components to the Earth's orbit would be necessary to build the space station. NASA decided to build a cost-efficient spacecraft that could make numerous journeys between Earth and space. But coming up with a design for a reusable space vehicle proved to be a challenge. It began developing the Space Shuttle in 1972, the same year of the last lunar landing. Bob Thompson headed the project. He was the Space Shuttle program manager for 11 years. Thompson had been involved in all of the previous manned space programs: Mercury, Gemini, and Apollo. The design and construction of the Space Shuttle was his final undertaking. He began by re-evaluating the technology developed for the Apollo program, analyzing the very foundation it was based on.
We didn't try to reuse all of Apollo. We were able to do Apollo because of what we call staging. You could have a first stage, help you get started, throw away a lot of weight, light another propulsion system, go so far, throw all that away. But I was throwing stuff away like mad. It gets pretty costly and it gets limited. So it was pretty clear in 1970 we would like to get away from throwing everything away to begin to learn how to reuse things over and over.
For a rocket to orbit Earth, it must reach the incredible speed of 7.9 kilometers per second. The rockets used prior to the shuttle were able to achieve such a high speed by detaching parts of their bodies at different stages. However, since the Space Shuttle cannot release any parts of itself, engineers needed to develop a more powerful but lighter engine. This is the Space Shuttle main engine, also known as SSME. Lightweight but powerful. To fuse these seemingly contradictory ideas, engineers developed a novel engine system. First, the liquid hydrogen inside the engine combusts, causing the turbine to rotate at an extremely rapid rate. At the same time, liquid oxygen is injected. As a result, a powerful chemical reaction occurs inside the combustion chamber. This engine produces a massive amount of power, more than 3 times the amount used to launch Apollo 13 to the moon. at an astounding pressure of 210 atmospheres. Huntsville, Alabama is home to the U.S. Space and Rocket Center. Every year, about 20,000 children from around the world visit here. They are participating in the immensely popular Space Camp program.
Let's see that bunny hop. Let's see you jump. There you go. Lots of hands. Make sure you're smiling. There you go.
This microgravity training chair simulates what 1/6 of the Earth's gravity feels like, making you feel like you're walking on the moon.
There we go. Wave to the people down on Earth.
The multi-axis training simulator creates the sensation of what it's like to lose control of a spacecraft. The camp's most popular attraction is one in which visitors perform work outside the spacecraft.
All right, now go to your right. All right, stop. Uncross your leg.
Satellite repairs are made from the robotic arm. Almost everyone has seen this on television or in magazine articles. The shuttles have brought space exploration closer to us. A graduate of Space Camp has even gone on to become a real astronaut. Dorothy Metcalf Lindenberger attended the camp when she was in junior high school. 20 years later, in 2010, she was aboard the Space Shuttle for a mission to the Kennedy Space Center. Upon arrival, the shuttle was found to be in terrible condition. During the transport process, a large portion of the heat-resistant tiles had been ripped off. This was disastrous for the shuttle. To create a reusable spacecraft, heat-resistant tiles capable of withstanding extreme temperatures had to be used. These heat-resistant tiles are made of silica, a material known to block heat transfer. However, silica tiles are soft and susceptible to breakage. After investigating why the tiles came off, developers found that the problem was with the tile's adhesive. Heat-resistant tiles contain many small air bubbles, and when a lot of pressure was applied, the tiles began to peel off. By reprocessing the surface of the tiles and making them harder, engineers were able to keep the tiles from ripping off due to vibrations and wind pressure. Three years behind schedule, the Space Shuttle was finally ready for takeoff.
It was a hard-nosed 10 or 12-year grind to build an airplane, insulate it from the heat of entry, put electronics in it, put flight controls in it so it could come back and land, build a rocket engine that would give you the ISPs you wanted so you could build that much weight and take it to orbit. It was all understandable. But it took a lot of work, a lot of money.
April 12th, 1981. The Columbia Space Shuttle was waiting for liftoff into space. This was the first time ever that a reusable spacecraft would be launched. To witness this momentous occasion, nearly 500,000 spectators came to the launch site. The winged space shuttle was a novel design, and the world viewed this as the start of a new era. Two astronauts were chosen to ride the Columbia Space Shuttle on its maiden voyage, Robert Crippen and John Young. Because it was a test flight, there were only 2 crew members. A decade-long experiment was finally being put to the test.
There's obviously an apprehension anytime you get ready for a launch like this. You know, that thousands of people have been involved, thousands of individual processes have had to take place. No one person can be there and see all of that, so you're somewhat apprehensive. Did everything get put in place as it should have been? Is everything going to work all right? So you sit and watch it count down and lift off.
8, 7, 6, 5, 4. We've gone for main engine start.
The shuttle released a plume of smoke and a ball of flames. It was engulfed in a bright, blinding light. "40 minutes after its launch, the Columbia went into geocentric orbit. The 2 astronauts' duty was to ensure that the shuttle's complex systems would work properly in space. And most importantly, to return home safely. In 2 days, the Columbia circled the planet 36 times before returning to Earth. The shuttle had opened the door for a new era in space exploration. After Columbia returned to Earth, more problems than expected were revealed. Nearly 150 heat-resistant tiles were damaged during the flight. The shuttle's second launch date was significantly postponed because of the additional time needed for maintenance. 7 months after its maiden voyage, Columbia was ready for its second flight. A lot more was at stake. It was the first ever attempt to launch a shuttle that had already been to space. This was the moment of truth, to see if this space shuttle was in fact a practical vehicle for space exploration. 2 astronauts were chosen to embark on this important mission, Joe Engle and Richard Truly. Truly played a role in the development of the shuttle and was in charge of testing the landing functions. He is still active in the world of space exploration and continues to advise the next generation.
The flight that my first flight, STS-2, was really important in the series of flights because it was the first time that we had ever reflown a spacecraft.
We have ignition of the solid rocket boosters and liftoff. Liftoff of America's Space Shuttle, and the Space Shuttle has cleared the tower.
This was Truly's first trip to space. A huge sense of responsibility weighed on his shoulders.
Hey, good. The old eyeball looking out the window is the best alignment device, I think.
And we've got a great picture from camera Delta of the arm going down into the cradle.
On the last day of the flight, President Reagan visited the control room to offer encouragement to the two astronauts.
Let me just say, I'm sure you know how proud everyone down here is, and how this whole nation, I'm sure the world, but certainly America, has got its eyes and its heart on you.
For 2 straight days, Truly and Engel worked tirelessly on the shuttle's performance tests. And they proved that the space shuttle was capable of making multiple trips to space.
You know, we were going to be flying this flight for years and years, and this was the first time that it had been reflown into space. And sure enough, we did. Here we are decades later, and we have flown it way over 100 times. But this was the first time. And so it was a thrill for me to be, you know, involved in such an important flight.
The goal was to launch the space shuttle several dozen times a year. So by 1985, they had built 4 shuttles. NASA grew confident in the performance of their shuttles and called for other countries to join them in the exploration of space. Canada had already contributed a large robotic arm to NASA. And the European Space Agency had expressed its commitment to promoting research and development in space programs. With the shuttles now having the capacity to seat up to 7 passengers, they began carrying astronauts with varied backgrounds, including scientists and engineers. As a result, NASA could carry out a variety of missions, which included performing complex experiments and deploying satellites. To make space travel possible for anyone at any time. The Space Shuttle ushered in a new age where this dream could become a reality. But the shuttles, which had made multiple successful missions, were confronted by a sudden tragedy.
Space Shuttle mission, and it is cleared.
January 28, 1986. The Challenger lifted off from Kennedy Space Center. 73 seconds later,
1 minute 15 seconds, velocity 2,900 feet per second, altitude 9 nautical miles.
it suddenly exploded as the world watched. The Challenger, along with its 7 astronauts, was engulfed in flames. It was the first time in NASA's history that lives were lost during flight. The Challenger disintegrated. Its bits and pieces were scattered all along the coast of Florida. The Space Shuttle program was suspended, and a detailed investigation followed the accident. The commission in charge of investigating the cause focused on the footage of the launch. The Challenger lifted off as expected. But flames started to come out of the side of one of the rocket boosters. Rocket boosters are made of several components. The fire's point of origin was in the section that connects 2 parts of the rocket. The O-ring is a mechanical gasket made of rubber placed in this section. It acts as a seal to prevent high-temperature gases from leaking. It is a critical component. The commission started to believe that the O-ring may have caused the accident. On the morning of the launch, temperatures were unusually low at the Kennedy Space Center. Some surrounding areas had dropped to below freezing. Because of the cold temperatures, the O-ring hardened and lost its sealing function. This led to a gas leak, which caused the explosion. Upon further investigation, the commission found that NASA had insisted on proceeding with the launch despite the low temperatures in an effort to increase the number of shuttle flights. This is John Logsdon. For years, he has been advising the government regarding space exploration policy. He believes NASA's overconfidence in the Space Shuttle program contributed to the Challenger accident.
And NASA and the U.S. space community thought they could do anything. And so on paper, they said if we can solve these design problems, we can operate the shuttle like an airplane, launch it 50, 60, 70 times a year. And that was basically a fantasy, given the technological uncertainties and the complexity of the vehicle. The Challenger accident ended most of that self-delusion.
NASA was subject to harsh criticism. The loss of 7 astronauts' lives, along with the shuttle, was a crippling blow. There was even talk of how NASA would not be able to recover. It was the worst crisis the space agency had faced since its founding. Richard Truly, who was on the second space mission, headed the program's overhaul. He assumed this responsibility after wrestling over whether or not to take the position. The project to get the shuttle back into operation was called Return to Flight.
One of my biggest problems, though, was not technical at all. It was a leadership problem. In order to get the team to work together again, this is to lose a spacecraft and 7 people was terribly disappointing and heartbreaking to all the people in NASA that worked on the program. And somehow I had to create a team of people that eventually would get back to a new flight.
A task force of military officials and former astronauts who were experts in their fields was assembled. They worked on changing the mindset of the employees. Under their leadership, their goal was to restore the workers' confidence and trust in NASA. The task force dealt with one technological challenge after another. The rocket booster sealing joints, which connected the different parts of the rocket, were strengthened to improve safety. The number of O-ring seals was increased from 2 to 3. When it was determined that there were areas of the engine and fuel tank that could be improved, the design of the shuttle was re-evaluated. Multiple changes were made to the Space Shuttle. It may have looked the same from the outside, but it had undergone a complete transformation. On September 29, 1988, 2 years and 8 months after the Challenger accident, the Space Shuttle was set for relaunch.
3, 2, 1, 0, and liftoff! Liftoff, Americans return.
All across America and the world, people watched as the Space Shuttle Discovery took flight once again. It was the moment that everyone had been waiting for.
The Challenger accident and 2.5 years of the hardest job I ever did of, getting the shuttle back together. And I was deliriously happy when we finally lifted off on that Discovery mission in 1988 to fly again. That particular day was a beautiful day for me.
The Space Shuttle succeeded in overcoming tragedy and resumed its odyssey of exploration. April 24th, 1990, the 10th flight after resuming operations. Discovery was carrying out the Space Shuttle's most important mission to date. It would transport a telescope to outer space, one that would help unravel the mysteries of our universe. The Hubble Space Telescope is a 13-meter-long giant space telescope. In outer space, there is no atmospheric interference. Because of this, the Hubble can take clearer images of distant stars and galaxies. This precision instrument can only be transported and have maintenance performed on it by the shuttle. It is the only spacecraft that can cushion the telescope from the impact of liftoff and make multiple trips to space. For this reason, the Hubble's size was designed to fit perfectly inside the shuttle's payload bay. But in order to keep interference from the Earth's atmosphere to a minimum, it was necessary to transport Hubble to an altitude of 600 kilometers. This was approximately double the shuttle's normal altitude of around 300 kilometers, and was nearly the limit of what was considered safe for the shuttle. Discovery, with the Hubble on board, managed to safely reach its target altitude.
Discovery Houston, we're getting some real good payload bay television downlink, and we see that Steve has been hard at work getting the RMS deployed.
Using the robotic arm, the crew began transporting Hubble out of the payload bay.
You know, pitch is about 4 degrees off, attitude-wise. Okay. Maybe that's what's making it look like that. You're gonna pitch it up. Okay.
Discovery, go for Hubble release.
Okay, we have a go for release, and we're going to be a minute late.
Okay.
Hubble was deployed into orbit at an altitude of 600 kilometers from Earth. The shuttles made 5 more trips to the telescope to perform maintenance and make improvements. The Hubble telescope continues to send us images which could hold the key to unlocking the secrets of the universe. The success of Hubble enabled NASA to finally shake off the nightmare of the Challenger accident.
Certainly, you could not have Hubble without the shuttle. Hubble was able to give us all these years of remarkable discoveries and images that still thrill people. I would say that the symbiosis between Shuttle and Hubble is probably the program's greatest achievement.
As the shuttles were making their comeback during the mid-1980s through the early 90s, historic changes were taking place back on Earth. The Berlin Wall, which symbolized the Cold War, was torn down, marking the end of the Cold War era. This wave of change also reached the world of space exploration. In 1993, Russia joined the International Space Station program, which was being developed by the nations of the Western Bloc. The U.S. had long dreamed of building a space station, and the shuttle program was created to help make this happen. By overcoming the divisions that had existed between the Eastern and Western world, this dream became a reality.
And liftoff of the Space Shuttle Endeavour with the first American element of the International Space Station united.
Components of the International Space Station supplied by the U.S. and Russia began to be transported into space. As expected, the shuttle played a major role. After reaching a geocentric orbit of 400 kilometers, construction of the space station began.
You have a go to install Unity.
One and a half. 6 inches. Halfway down. Keep it coming. Grapple.
Okay, I'm watching.
Good job. You caught on the rifle.
The International Space Station project was set into motion. 15 countries, including the US, Russia, and Japan, participated in the program. The world was steadily building a foothold into the outer regions of space. In May 2008, Japan provided an experiment module for the space station. It was given the name Kibo, meaning hope. For 13 years, the space shuttle traveled back and forth between Earth and the International Space Station. The United States and Russia were able to work together in space, where there are no boundaries. The space shuttle's accomplishments made the unthinkable possible. In January 2003, 7 astronauts were on board the Columbia for a scientific research mission. They conducted experiments in a variety of different fields, including life science and medicine. After completing a 17-day mission, all they had left was the return journey to Earth. But tragedy would strike for the second time in the space shuttle's history.
Columbia, Houston, comm check.
During its re-entry into the Earth's atmosphere, the Columbia suddenly disintegrated. This shocked the entire world. The shuttle shattered into thousands of pieces over a 5,000 square kilometer area. A thorough investigation was conducted, just like after the Challenger accident. A piece of foam insulation that had broken off from an external fuel tank shortly after liftoff was found to have caused the accident. The broken piece had smashed into the shuttle's wing, creating a hole. Unaware of this, the Columbia kept on flying. When it re-entered the Earth's atmosphere, superheated gases penetrated the hole, causing the shuttle to disintegrate. All 7 astronauts died in this horrific disaster.
all Americans today are thinking as well of the families of these men and women who have been given this sudden shock and grief. You're not alone. Our entire nation grieves with you.
The Space Shuttle program was again in danger of being scrapped. But after a hiatus of 2 years and 6 months, the Space Shuttle resumed operations. Leaders of countries interested in completing the International Space Station, as well as the public, called for the program's continuation. After the Columbia accident, the shuttle made 21 additional flights. The space station was nearing completion. However, massive amounts of money were spent to ensure that the shuttles kept running safely. Upon their return, the shuttle's maintenance included the replacing of broken heat-resistant tiles and the dismantling and inspection of its engines. Because of the increasing cost of its upkeep, a single mission cost over $1 billion. Although the shuttle was a reusable spacecraft, the cumulative effect of these repeated trips took a heavy toll on its body. In 2004, President Bush announced that the shuttle would be retired after construction of the space station was completed. But the technology that was developed for the shuttle is now being applied to the next generation of spacecraft. SpaceX, a private company that was established in 2002, is using NASA's technology to develop new types of launch vehicles. In December 2010, the firm's unmanned spacecraft successfully circled the Earth twice before re-entering the atmosphere and safely returning to Earth. This company ultimately aims to build a manned space vehicle. NASA also has announced a plan to create a new type of spacecraft. Its goal is to go beyond Earth's orbit and carry out manned expeditions to Mars. The technology that was developed for the Space Shuttle is helping to open the door to the outer regions of space. In June 2011, Atlantis was transported to the launch site for the Space Shuttle program's final blastoff. From the initial liftoff in 1981, over a span of 30 years, the 5 shuttles circled the Earth more than 20,000 times. The shuttles and its crew took part in numerous daring adventures.
For 30 years, it has carried science payloads, defense payloads, communications satellites, hundreds of people into space, and has, for 3 decades, literally been our space program.
Will there be a next shuttle? I personally think there will be. I don't think it's the last big space plane we're ever going to build. There will be other vehicles that do similar to what the shuttle does.
The shuttle had made dreams come true for mankind. Their arrival conveyed the dawn of a new era in space exploration. Though the shuttle's history was filled with hardships and tragedy, they brought us closer to space.